Okay, this is the open working meeting of the DETNet working group. Give people a few more minutes to get here. Okay, this is David. I've pasted the agenda over in the note tool. It'd be helpful if a few people could go over to the note tool and take notes as the discussion goes along. Let's see. Okay.
Hello, David.
Hello. Still getting organized here.
Sorry, I just to check my microphone. Thank you.
Okay. Okay. This is the note well slide, which applies to this meeting. If I click there, let's see. Looks like I can make that work. Gee, that came out rather small. Never mind. We'll do it the other way. There we go. That's more legible. Okay. Appreciate everybody um, who has come to attend. This is the agenda, and we're going to go ahead and bash it a bit. The Under process-oriented topics, I believe EJU has an initial test run of the CQF queuing and scheduling mechanism from TSN against the criteria and requirements draft. So we'll include that in the discussion under item 1. And under item 2, it's detailed presentation on the time slot mechanism. Anybody else want to go and bash the agenda? Okay. Anybody want to make any comments or ask any questions before we take a look at what Iju has produced? Okay. I'm hearing a lot of quiet. I hope people can hear me. Iju, do you want to take the floor? I'll stop sharing, and you can go ahead and show us what you've done.
Yeah, thanks, David.
There, with luck, that worked.
Give me a second. It looks like
Yeah, looks like the bits are taking their time getting out of China.
yeah, it looks like I may I have some problem to share the screen. I don't know. The permission denied. It says.
That's weird.
May I try again? Should I ask
go right ahead.
to share the screen again?
I will keep clicking on yes. Okay, Meet Echo thinks you have permission to share the screen.
Okay, so let me try here. Sorry to take a little bit time here. I think I have some problem here. Since this is only a single page one, how about I send to you right now? Then
sure.
You help to share it.
Yeah. Okay, I'll make it work. Now we got it. Now instead of the bits getting out of China, it's going to be how fast can Dell process email from China? We can have a real-time benchmark here.
Okay, I'm still typing.
Okay.
Sent.
Okay. The other thing you might try to do is if you can get to the materials of this meeting in the data tracker, you can probably propose the slides there. I can accept them. We can try, we can see whether that works.
Upload it to the data tracker.
Yeah, if you go to DETNet and data tracker and click on meetings, there should be a line for this one, which calls itself interim 06. And I suspect I see a slightly different screen because the data tracker apparently thinks I'm in charge of this meeting. But there should be a link there where you can we at least propose the slides, and then we'll see what happens. Wait a minute, hang on. Your email has arrived. Let me go save that, and I will go share it, and away we go. Aha! Just had to threaten it with a data tracker. Now we know how to make Meet go do things. Okay.
Competition?
There's at least 3 bad jokes hiding in there trying to get out. Okay, and now about 4 more clicks, and we should see your masterpiece. I lied, it was 5. All right.
Thanks. So this is a single page for the kind of very initial CQF evaluation with the scaling requirement. The CQF here refers to the published IEEE standard 802.1 QCH 2017. So because I remember last time we somehow talked about that it may be worthwhile that try to start with the evaluating the original CQF. So this is what I tried to do yesterday actually. So so this is still draft basically. So I put the requirement from the scaling requirement document here. There are basically 8 requirements, and I think for the 6 and 8 they are not directly relevant to the queuing, so I grade them. So and check them for the rest of the requirements one by one and give some of the comments so we can discuss it. So the first one is to tolerate the time asynchrony. So the CQF here is a no, because because in the original TSN requirement, the time sync is a mandatory. So and in the CQF, especially in the CQF, all the nodes need to rotate their transmission buffers, normally 2 buffers, according to 1 wall clock time. So that's a no. So kindly note we are evaluating CQF, not the TCQF thing. So that's the first one. I think you can stop me anytime for each of the item. That's
keep
for
going.
item
I
1.
think this is just
Okay.
the sort of thing that I think was needed. So carry on.
Okay, so the item 2 is to support the large single hop propagation delay, and CQF here is a no, because the propagation delay, in theory, it should be much lesser than the cycle interval time TC in order to make the utilization practical. And if the propagation latency, say, is so large, normally if 1 kilometer, it would take like 1 kilometer take 5 microseconds. So in that case, let's say only a few kilometers, it will make the only the propagation delay, for example, like the 10 or something microseconds, then it will make the TC, the the cycle interval time extremely large. And we know in CQF, the end-to-end boundary latency is proportional to the cycle time TC. So that would be hard to achieve the end-to-end boundary latency. So the CQF is I put a no here for item 2. So I'll move on to the item 3, which is accommodate the higher link speed. This is kind of conditional, I think. So I put a partial here. The CQF, the fundamental CQF, I think it was not designed for the high link speed. So I believe it was not tested for the speed higher than 1 gig, as far as I know. So that's by theory. If we have a high link speed, then then there are some background assumption that we want to achieve the tighter end-to-end boundary latency with the higher speed link, so that again we want to make the cycle time smaller. And with the higher speed link, it doesn't necessarily mean that the processing latency variation or clock accuracy is also better. So in that case, they could be relatively large time variation in higher link speed compared with the cycle time we can achieve in higher speed. So that is, it is harder to determine from the arrival time to determine from absolute arrival time about which cycle a packet was sent from the upstream node. So I put a partial here. Then item 4, the requirement says be scalable to the large number of flows and to tolerate the high utilization. I try to split them to 2. The first one is to be scalable to the large number of flows. I put a partial here for CQF because the original CQF, actually the transmission control is based on the traffic class gate control, which is quite scalable because normally the traffic class is only 8. And if it is a 2 buffer CQF, then normally this 2 buffer takes 2 of the traffic classes. So it is transmission control is scalable. At the same time, the CQF requires at the input port, normally there is a stream gate filtering and policies. Sometimes it's called PSFP, and it needs to be applied either to per stream or some aggregated way. So it really depends on how the user try to aggregate it. If the user want to really finer granularity control, then the stream gate filtering could be based on the per stream. But normally it is not what we are trying to do. So it is in aggregated way is more possible. So I put a partial here because it could be aggregated at the stream gate. And the second part for item 4 is to tolerate the high utilization. I put a no here because in CQF, not all the cycle time is usable for the real data traffic. The utilization is constrained by the ratio of that time to cycle time. So in smaller cycle time cases, for example, the tenths of microseconds, cycle time, it would be very hard to achieve the high utilization with the normal CQF. And item 5, prevent flow fluctuation from disrupting service. For this one, I put a partial here. So because if it is if the flows are all compliant, when I say compliant, basically it means every single stream or flow at the ingress point, it always fits into what has been agreed on the traffic pattern. So for the compliant flows, that should be all right. For non-compliant flows, because the CQF normally use the number of buffer is very limited, so it is fundamentally is only 2. So it will start to drop the packet. For example, if one of the if the packet from flow 1 is designed for buffer 1 going into buffer 1, it missed that cycle. So then if it is missed the cycle of the buffer 1, then it rotates to buffer 2. Then buffer 1, because it already starts transmission, then fundamentally the buffer starts transmission, we will stop dropping the buffer into that. Drop the packet into that buffer. So when I say drop, I mean put the packet into that buffer. So basically, that packet could be dropped. So that's this part. Actually, I'm not so sure because it sounds a little bit item 5 kind of relevant. May be relevant to item 4.1. So anyway, I put a partial here. Then we jump to, we ignore item 6, we jump to item 7. And the original text, it says to be scalable to a large number of hops with complex topology. When I try to think about this, because I think my evaluation actually doesn't go with anything with complex topology. So that's why I cross out with complex topology here. Only think about the large number of hops. And there is an implicit assumption is with large number of hops, we still want to achieve bounded end-to-end latency. So I put a no here because in most of cases, 2-buffer CQF normally supports like a few hundred, at least a few hundred microsecond cycle time, because the buffer needs to be sufficiently large. There are only 2 of them, so it needs to large enough to absorb all the converged flows. And at the same time, the number of hops is relatively is roughly equals end-to-end latency over the cycle time. So if we say the number of hops needs to be large, then for a given end-to-end latency, then the number of hops actually is limited by the cycle time. So because we don't, for example, if the number of hops is really go large, like a 100 hops, then it would be could be problematic because that will cause, in order to tolerate, in order to support that, then the time cycle time has to be really small. So so I put a no. I think probably I should put a partial here, but anyway, I put a no here because in that case, in some of the cases, I think it's when the number of hops is extremely large, it will become impractical. But at the same time, the jitter bound is okay because no matter how many hops there, the jitter bound is almost always 2 times the TC, so it sounds okay here for the jitter bound. So that's basically what I drafted here.
Okay, this looks really good, and I like the short remarks.
Hi, Izhou. I have some comment for the 5th part. It is mentioned that prevent flow fluctuation from disrupting service. It seems like you want to mention that there are only 2 queues and there is no extra queue for burst, for example. But I'm not sure it is suitable for CQF because in the mechanism of CQF, it is there is bandwidth reservation from before the flow goes into the network, and also there is traffic specification to limit the behavior of the DETNET flow. So although there is only 2 queues for CQF, still maybe gives limitation to the to what kind of flow can be allowed to use these mechanisms. But at once it is allowed, it means that it can handle this. So I think it can prevent flow disrupting. So maybe it can modify it in another mode if you want to highlight that the queues of CQF is not enough.
Thanks, Jason. Yeah, so I think that's also
So
the
sorry
reason I
that
put a partial.
So sorry, I'm still at home, so my dog
You
is.
go ahead first.
I thought that was a great
Yeah, sorry.
comment from the dog.
It's just apologize. Sorry about it. Just go ahead.
Yeah, so for item 5, what you said, I think that's also the reason I put a partial here. So you are right. In normal CQF, for example, there are only 2 buffers. Then normally we put the cycle time or buffer to be large enough, so that it won't. I think it won't be like if I only have 2 flows, then I make the cycle time so small that only can carry the current 2 flows. So if we really want to use the CQF at the very beginning time, we will try to make the so-called over provisioning huge, basically larger, so that if there is additional flows coming up, then I can still try to fit into the current buffers. So in that case, I consider them all as the compliant flows. So so for the compliant flows, I think that's all fine. So as what I think that's consistent what you said. That's the for the long. So the corner case is just for the non-compliant flows. So in that case, it would cause some problems.
Yeah, I think I understand your point. My concern is that, you know, even we have some other enhanced mechanisms based on CQF, it is, I think it is still still no approach to guarantee for non compliant flows. So the concern is just that we
Okay.
cannot. Yeah, because if the flow's behavior is out of the expectation, then although we have more queues, more than 2 queues or more, it is still have some, you know, risk that that kind of flow cannot be handled probably because there's no reservation beforehand.
Oh, okay. I got your point.
So
At the same time,
I think there is a large latency. Sorry. Oh, and I forgot to be in the
Thomas,
queue.
you go ahead.
Let me get in after Gino. Sorry.
Oh, Gino, you. Oh yeah, sorry, I
Gino,
didn't
I
check
think
the
you're
queue.
next. Go ahead.
Okay, thank you. I also have a question about the.
Oh dear, your audio is not very good.
It is a regulating aspect. I think it is control plane has to do something about it. And if it is within the admissible region and the flow is admitted already, but what that means is the dynamic changes of the flow join and leaving, then it has to be handled within the data plane, I think. If that is the case, if the packet has to be dropped because of the buffer space, then it is quite unacceptable. And I would say it is not acceptable. So the evaluation of number 5 should be something like no or negative. Thank you.
So I guess the question here, Tulos, I'll go to you in a minute, is what kind of flow fluctuation needs to be defended against? And part of that appears to be a question about what we assume on admission control. Turles?
Yeah, so I'm comparing with the section 3.5 of the requirements document, which I think is what this is against, right? So maybe the only fundamental improvement on this otherwise very nice slide would be that we put the numbers from the requirements document and the draft version in there against which this is, right? So hopefully this is 3.5.
Yeah, it is.
Not, yeah, right. So there are 3 paragraphs. So the first paragraph on 3.5 is I think the first 2 paragraphs really are about the burst accumulation problem. And I think from that perspective that if I look at all the different algorithms, I think we have seen few that were arguing that we can deal with burst accumulation as something across multiple hops. But to me, against the requirement, that would be kind of not met because it does incur the additional problems. I think CQF is fine with not causing burst accumulation across multiple hops. So in that respect, I think it is fine. The non-compliant flow stuff. So I'm not sure how to match that up against. So I think it's an interesting consideration in the evaluation, but I don't think we have text in 3.5 that it matches up against, right? In terms of how relevant do we think non-compliant traffic is, and maybe that's something to take back to the requirements document. So I think that would be it, right? So I would say it's in full compliance to what I can read from 3.5, and the other aspect, I think, if that is seen as something useful about the non-compliant traffic, then I think we should try to see if we can write that in as a requirement and see if we can get agreement on that. Because I'm not sure right now how to best translate that. Does that make sense?
Mm.
I think that makes sense. I'm sorry. Go ahead, Ichiro.
Sorry, I think, yeah, because I'm also rereading 3.5, so it will be more clear to me that if we directly use something like the burst accumulation in as the exact text in the requirements, so what Thomas said, I think that makes sense to me. Yeah.
Okay, and it also sounds like there's an assumption being made that, or an assertion being made that non-compliance flows are outside the scope of this requirement.
If you're saying that if we want to talk about non-compliant flows, that it should go into a different requirement, I think that's fine, so that we separate it better.
Okay. Peng as...
Yeah, so if I may summarize, it looks like for the item 5, we think the evaluation here basically should be a yes. Because the remarks would be something like, because this requirement talks about a burst accumulation, and the CQF has already can deal with it. So that's what I heard.
So if the draft were revised appropriately, Peng, are you hearing or seeing anything here that suggests refining the text in the requirements draft? I'm having a hard time hearing you, Peng.
Sorry, I can check the listening with
Yeah, no, it's not working. Okay, Ishu, as you revise this, could you work with Peng and the requirements draft authors to make any changes there that seem to be necessary?
Yeah, sure, no problem.
Right.
Yeah.
Okay, then I have a
Him
couple
and
of
the
other questions, most which I think come down to what certain terms mean. I'll start with 4.2. It's what did you assume that high utilization means? It sounded like you were assuming that DETNET traffic could be 100% of the link, in which case dead time is a problem.
Did I lost? Did I get lost or?
You're still there. You didn't hear you for a minute.
Oh, so I'm not sure I get your question from on and off
Oh, sorry.
network
The question
connection.
was
Now,
question was when you did the evaluation, what meaning did you give to high utilization? Was it all of the link?
oh, so in my understanding, normally the DETNET flows would not take up all the take full link speed, link bandwidth, and normally people would like to do is somehow to reserve the sufficiently large resources. For example, 40% of a 1 gig. That makes it a 500 meg reserved for the DETNET flows. In that case, when I say the utilization, basically it is only talks about the portion that's usable over the reserved bandwidth for DETNET flows.
That might be useful clarification to get into the requirements draft.
Okay.
It's not there already, which is that it's not high utilization in isolation. It's high utilization of the bandwidth reserved or provisioned for DETNET.
But ultimately, this is a problem when the bandwidth provisioned for DETNET gets closer to the percentage that's usable, right? So
when you say
the
usable
longer
means
the links are, the
100% of
larger
the
the dead
reserved.
time. So the possible utilization of DETNET even goes to zero at some length of let's say 2 miles or so of a link, right? So
I think you're up in item 2 under propagation latency at the moment, Turles.
which point are you looking at?
I'm looking at 4.2, tolerate high utilization, and trying to gently explore what high utilization means here.
Okay, how do we separate that from number 2?
I believe number 2 has identified that CQF, as you explained, does not scale to large single hop propagation latencies due to the necessary relationship between propagation latency and cycle interval time. So setting that aside for a moment, maybe the question is, assuming number 2 is not a problem, what does high utilization mean in 4.2?
Exactly, but I think that's more a question against our requirements document then, right?
Yes. Yes, I agree.
Let me try to get up the text there and see if there's clarification in there.
Yeah.
Sorry, this is 3.4.
And you're seeing some of the method here, which is let's use this to figure out what does requirement stock actually mean, and can we effectively use it?
So, I mean, we have these mechanisms that were proposed to operate on stochastical means, as opposed to deterministic means, and those are the ones that to me were immediately visible as something that start to have problems with high utilization, right? Because effectively they create stochastical latency longer than the bounded latency, and the higher the utilization, the higher the probability at some point in time, you have to drop too many packets because they're too late. The higher the utilization. So that's where, even without reading the text, I would know what I think, how to interpret high utilization. I really don't know how to interpret high utilization in CQF, right? With or without taking the propagation latency account. So that's an interpretation issue. So now, what do I think about our text here in this respect? Can we just,
That
at this
could be
point in
another.
time, agree that we may have a
Hey,
problem?
Turles, let the
Sorry.
issue in, please.
So I think there might be another aspect because I think the item to the large propagation delay would be a big contributing factor to the high utilization issue or consideration. But even we don't talk about item 2, which is the large propagation latency, there could still be some other aspects to consider that might affect the high utilization. For example, the large time variation, either caused by the clock inaccuracy or caused by the processing latency variation. Over the large scale network, there are so many different kinds of nodes, and some of the nodes they have larger processing latency variation because the incoming port actually there are some are probably from different line cards. Then they are when the packet is kind of arbitrated to a single output port, and they may experience different processing latency internally. So that's also a contributing factor to the high utilization, especially when the cycle time is small.
Yeah. So maybe and in fact, you've already started doing this. So basically, suggest you to continue what you've already doing. Maybe the thing to do is to focus on circumstances under which high utilization is not possible, and to be clear that we're talking about high utilization of whatever fraction of the link is dedicated to DETNET.
Actually, I want to, I want to add one more point about the link utilization, because for the mechanism of CQF, there is no difference between each cycle. So if one flow want to make a reservation along the path, it has to reserve a time slot, for example, in each cycle. So it means that although the flow is not very large, it has to occupy some space in each cycle. That brings some bandwidth waste. For example, if we have some advanced mechanisms like CSQF, as I have mentioned, there is a difference between each cycle. So if the flow is quite small and maybe it can just occupy some space in each, for example, 5 cycles, this allows that for the same network, it can have more flows in that network. So maybe that is some aspect about the link utilization.
Okay. Turles?
Just thinking about that, yeah. So I think that's another interesting interpretation. Yeah, I actually like that one as well. So I need to take a note on that one, how we capture this. I had more problems with David, what you were saying in terms of is it fine if there's some overlap with you know, the propagation latency and the high utilization? I mean, if basically my links are so long that I can only use 10% of the link bandwidth for DetNet traffic, and I can use the 10%, is that still high utilization?
Oh, okay. Maybe a better way to approach that would be to point out that large single hop propagation latency, and in particular large variation in single hop propagation latency, makes high utilization difficult.
Right.
Issue?
Song mentioned just now is quite consistent with the last paragraph of current 3.4. So it to me maybe try to not to over provisioning or make the more over provisioning limited is a better word than the utilization here. If we try to so for me it looks like the link utilization in here in current requirement document, it covers different parts, and one of the part is the over provisioning issue actually, and it's uh, on the other hand it overlaps with item 2 because the large propagation delay is a big contributing fact to the high utilization. So that's just my observations. So if possible, maybe we could kind of um, revise the text of the document. I mean the requirement document to make it clearer. For example, um, put the over provisioning issue as 4.2 and move the high utilization to as a separate paragraph for item 2. That could be one way out, but I'm
That would
not
be
too
great.
sure.
If you could send an email with that suggestion to the list, that'd be wonderful.
Okay.
And then I have, I want to shift, anyone have anything else on item 4 before I shift to item 7? Okay, so item 7, the same way we were having fun with trying to understand what does high utilization mean in 4.2, item 7, I think we're going to have fun understanding scalable. Because each exercise I understood you to do was to hold the required end-to-end latency constant and scale up the number of hops. And that's certainly one way to do it. Another way to do it would be to say, well, no, I'm going to have an end-to-end latency that grows as my number of hops grow. And I guess the question is which one or both of those are consistent with the requirements draft?
For a given latency. So I guess the assumption is for a given end-to-end bounded latency. That is given. And we compare, for example, 10, a number of hops is 10 and number of hops is 100. Whether whether it can still meet the original the required bounded latency, end-to-end latency. But certainly if the required bounded latency for end-to-end is so big, for example, it's like a 1 second something or two, it's like a second scale, then it is fine, I guess. So only when the required end-to-end bounded latency is, for example, at least the millisecond level, then the number of hops would be a should be a fact to be considered whether it's scalable uh, to that number of hops in order to still achieve that quite tightly required end-to-end latency. That's my assumption, I guess.
Okay, I mean, and I just called up the requirements draft, and 3.7 is very, very short. So everything we've talked about and more could be included under what scalable means. So perhaps we need some expansion of text in 3.7. If I take a fixed end-to-end latency and scale up the number of hops, sooner or later the time allocated to each hop is going to be too small. There's going to be some minimum propagation delay in there. So that makes me wonder what's scalable, or rather scale may need to refer to not only number of hops, but to use of end-to-end latency bounds that are plausible for that number of hops. So if you scale up number of hops, perhaps the end-to-end latency bound also has to scale up slightly. Anyhow, Peng, I hope you and the scalability and the requirements draft authors are taking notes here, because this certainly looks like a place where some more guidance in the requirements draft would be very useful. Jinu?
Oh yeah, thank you. Regarding the number 7, I agree to David that the number of hops means a large network. So it deals with the scalability. I think the scalability of CQF depends on the feasibility of slot scheduling. Can we schedule slots to millions of flows in a very large network? That is the question we have to answer. Yeah, thank you.
Okay. An issue for clarity. None of this is intended to criticize what you've done. Somebody had to go figure out what was going on here, so thank you for getting started.
When I try to draft this out, I find there I just want to remind there could be some misunderstanding that we when we read the paragraph, because in item 7 it only says be scalable to the large number of hops. Actually 4.1 is the one that most likely we care more about, is be scalable to the large number of flows. So that's a difference. It's a number of hops and number of flows. Yeah.
Yeah, I agree to that. Number 4.1 and number 7 is the similar problem. But the one that I want to emphasize is that we have to deal with the scalability of the slot scheduling. The allocating slots to flows is a very difficult task, and it usually cannot be run in real time. Thank you.
Okay, and that would be a comment on 4.1. Xusong?
I think I understand the concern from Gino, and I agree that the scalability is not equals it doesn't equal to scale. So maybe, but still, you know, because this is some evaluation of CQF mechanisms, there is some limitation in CQF. For example, how many flows it can provide latency guarantee, and how many hops it can provide to the path calculation. If we have done something more based on CQF, it can make it better. I think it is still can benefit the point of scalability. So I think there is limitation for sure. How many flows the network can carry and how many hops can meet the end-to-end latency. There will be a limit for all the mechanisms, I think. But the evaluation point for CQF is, I think, provide the comparison reference for some new mechanisms. So if the new mechanisms can do better in these 2 points, it can be more scalable. It's but it's not unlimited scale to any case. Maybe we can point this out.
Yeah, that might be good to add to the requirements draft. And one of the themes here is, yeah, we're talking about CQF, but what we're really talking about is how do we go about evaluating a mechanism against the requirements in the requirements draft? And better to, once we figure out how to do it, we should be doing it the same way for all the new mechanisms. So better to do it here and learn the lessons with something that exists and is understood. Chuan?
The point 7, I think for the CQF, maybe maybe they're partial, and because the CQF can guarantee the jitter, it is the 2T, and cannot guarantee the end-to-end latency because it will be n multiplied t. So I think if the 7 is being scalable to a large number of hops to achieve end-to-end latency, it will be no. But if it is to achieve end-to-end jitter, it will be yes. So I think the 7 requirement can be clarified to 2 parts: end-to-end latency or end-to-end jitter. So the CQF may be partial here.
In particular, I think it would be very, very useful for the requirements draft to indicate whether the end-to-end latency scaling up with number of hops is the minimum end-to-end latency scaling up number of hops is acceptable or not, or whether we're talking about large number of hops against a fixed end-to-end latency. That's sort of where the discussion between Iju and I started.
Yes, thank you.
Okay, so Iju, I guess you'll try to refine this and suggest changes to the requirements draft based on this discussion.
Send it to you again.
As a course on the requirements draft, right? So would be good if we can on the mailing list repeat what we see as issues of the mechanisms, right? So, and then I think maybe instead of trying to generalize it, we can just simply start adding as examples to the appropriate section. So I think what I heard from Yizu here is that the adding up of the dead intervals on a per hop basis is a factor that impacts scaling across multiple hops. That's the way on how I would describe that challenge to requirement 7 here as one example. And whether we agree that that should be in 7 or that is appropriate for number 7, that's a different point. But if we kind of start to collecting the challenges, that we see with CQF against the individual points or for other mechanisms. I think that helps to clarify.
Mm-hmm. Examples are always useful. Any other questions or comments on this? Xiaofu, go ahead.
Okay, thank you. So I have sent the mail to the design team to say that we just wanted to submit a draft for all TSM mechanism to evaluate if each mechanism uh, uh, satisfy the requirements draft. So I think it is helpful to add more examples in a single draft to describe the. Okay.
I would agree. I would encourage other people to follow Ishu's lead here and put together something like this. This slide will be uploaded, so it'll be available if you want to start from it as a template. Okay. Ishu, thank you very much for doing this. You gave us something that we that we definitely had some very interesting discussions about. All right, now let's see if, hang on, try that. Aha. All right. Okay, and now, hang on a minute. I am not the fastest in navigating through Meet Echo. Your slides are coming in a minute. All right. That wasn't what I wanted to do. Does somebody remember the details for getting directly to the shared meeting materials in a fashion that I can let Xiaofu advance his own slides? Nope. That's not it.
I doubt.
All right, I think we're going to have to share this. Xiaofu, do you want to share your own slides?
I think you can help me to share it. Thank you.
Okay, I'll share them. There is somewhere in here where I can get Meet Echo to share the slides and allow you to advance them. And I see other people do it, and I don't seem to be able to find it. So we'll do it this way. Okay, and
Okay, thank you. I have seen.
there you go. Tell me when to advance the slide, please. I will try. I will do my best.
Okay, thank you. So please turn to next page. Okay. This proposal is inspired by CQF and multi-CQF that is defined in IEEE. and we wanted to provide a more flexible time slot-based resource reservation and scheduling method to improve the service scale that the network can support. As we know that the two buffer mode of CQF or three buffer mode of multi-CQF make the scheduling behavior of the data plane very simple. But this comes at the cost of reducing service scale or bringing complexity of resource reservation. So in the figure below, we can see multiple sources may release fast independently to the idle cycle, and the aggregated traffic may arrive simultaneously at the same transit node and then want to access the same next cycle. So in order to avoid the cycle conflicts, some constraints should apply to the released traffic that is actually decided by the method of resource reservation. As we know, one method is that the summary of all released bursts during a single cycle on all source is less than the transmission capacity of a single cycle. In this case, the service scale can be supported is small. And another method is to carefully select the time moment, for example, T1 from T1 to Tn, to ensure that the bus 1, bus 2, and the bus n arrive at the same transit node at the different time. So this is the background of CQF and multi-CQF, and data is the reason why we introduced time-based QEMN for it. If there are not any other questions, so please turn to the next page. So the basic idea is to construct the forwarding resources of the link and propose a time slot resource. The time slot, the time slot resource refers to a time slot included in the orchestration period, with each time slot having a corresponding maximum reservable burst and unreserved burst. The resources of the orchestration period are visible to the service, and the length of the orchestration period is related to the service burst interval. However, if network devices instantiate the queuing resources according to the orchestration period, they require a large number of queues. For example, the number of time slots of the orchestration period we termed it as n. So we decouple the orchestration period from the scheduling period. The latter matches the actual capacity of the device. It just requires only a few queues. For example, the number of time slots of the scheduling period termed it as m. The n is an integer multiple of m. Then path calculation based on time slot resource reservation on each link and obtain a flexible mapping relationship between the incoming time slot and outgoing time slot on each node. It should to meet the summary of all nodes. The resistance delay must meet the total resistance delay budget. At last, on the data plane, we should map orchestration period time slot to scheduling period time slot to access time slot resource without conflicts. So this is the overview of the whole TQF model. Any questions? If no, then please turn to the next page. Next, we will discuss some primary steps. The first step is to determine the ongoing sending time slot when the flow arrives at the node. This is necessary for the outgoing time slot reservation to get an expected evaluation of residence delay. The following figure shows that how to obtain the ongoing sending time slot and head end. Assuming that the service traffic periodically reaches the network entry node. After traffic regulation, each burst of the burst interval has a fixed position relationship within the adjudication period. Based on this position, the forwarding delay internode. Based on this position and based on the forwarding delay internode, we can obtain the ongoing sending time slot for this burst. For example, the ongoing sending time slot of burst I is time slot J. Then we can allocate outgoing time slot J plus O for burst I. So this is the operation and head end. Please turn to next page. This figure shows that how to obtain the ongoing sending time slot and the transit node. For all bursts within the outgoing time slot I of the upstream node U, the mapped ongoing sending time slot is J of node V. Then we can reserve outgoing time slot J plus O for this burst. The basic mapping from I to J is irrelated with any flows that can be obtained by detecting messages. But the forwarding mapping from I to J plus O is related with the path established for the flows. Okay, that is the ongoing sending time slot decision. Please turn to next page. The multiple methods to get the mapping relationship between the incoming time slot and the ongoing sending time slot. This page gives two methods and maybe some other methods. So one method is to send a time slot mapping detection message. For example, the detected message contains time slot I. Then we can deduce time slot mapping for any other incoming time slot X. Another method is to send a phase difference of adjudication period detection message. Based on that, we can deduce time slot mapping for any incoming time slot X. The formula is tricky. I will not go detailed. If there is no question, please turn to the next page. So the second step is to reserve time slots and control plane. The controller may maintain a reservation subtask for each subbus in the service bus interval. There may be multiple subbus in the service bus interval, and each may consume different time slot. Firstly, at head end for each subtask, allocate a fixed outgoing time slot, G0 plus O0 according to the fixed arrival position, G0 of that subbus within the authorization period. Then the fixed outgoing time slot of the head-end node will map to a fixed ongoing sending time slot J1 and the first transfer node, and continue to allocate a fixed outgoing time slot J1 plus O1 and the transfer node, and under the transfer node, and so on till the endpoint. This basic observation or assumption is that the subbus does not arrive randomly at any node. This is a precondition for time slot resource reservation to get a bounded residence plane on each node. Please come to next page. However, the arrival position within the authorization period may have some deviations, but this must be limited. This position deviation should be considered during the resource reservation process to ensure that the world packets that arrive within the allowable deviation range can be successfully inserted into the queue. Instead, if the arrival position is completely random, it is difficult to allocate the time slot. In this case, more work is necessary. The first option is that under network entry, an explicit buffer can be placed before the TGF scheduler to store packets to get the fixed arrival position. Or we can take the second option is to let the scheduling period equal to the authorization period. This is interesting to directly store packets in the queuing subsystem. That means if packets with any number of time slots can have place to store. But we should know in any options, extra delay may be introduced, and the control plane does not avoid it. Questions? Okay, please turn to next page. This page is about to construct the time slot type of forwarding resource of the link. Each link has its own time slot resource information, which primarily includes time slot length, authorization period length, scheduling period length. For each time slot within the authorization period, it continues to include the maximum reservable bus. It should be less than the time slot length multiple the sales rate. And the second attribute is the unreserved bus. So the path can allocate the resource from the unreserved bus of each link that the path through. Okay. Please turn to next page. So here we give a possible algorithm of time slot resource information. Firstly, we can get the total residence budget, which is equal to the end-to-end delay required end-to-end delay requirement of the service flow minus the summary of wall link propagation delay. Then we can set the individual residence budget for each node along the path. They basically have two options. Firstly, the individual residence budget may be a single relative budget running for all nodes. That is gathered by the total residence budget divided by the number of hosts. The second option is we can maintain a list which containing different budget value for different nodes. Then we can allocate outgoing time slot on each node according to the result of individual residence budget plus the accumulated residence duration. Once the outgoing time slot is reserved, we can get the residence evaluation under the node by the following formula. The head and the transit may have different formula. I will not go detailed. Until we can update the accumulated residence duration according to the above result minus the residence evaluation. And the summary of all nodes residence evaluation must meet the total residence budget. This is a possible algorithm. There may be some other algorithms for the task setup. Okay, please turn to the next page. So the third aspect is to access the time slot resource and the data plane. The data packet color time the slot J of transition period. As mentioned before, each node instantiate the queuing resource according to the scheduling period. So you need to map time slot J of transition period to time slot J single quote of scheduling period. If the constraint O is less than M, is always followed during the reservation procedure. The mapping rule is that J single quote equals to J mod M. In the following figure, we can see the ideal arrival time of the bus. We let the bus fall into the ongoing single time slot J. But if the arrival is too late, the latest arrival that can be tolerated, we let the bus fall into the ongoing single time slot J plus O minus 1. That means the maximum position duration caused by the late arrival is O minus 1. Similarly, the earliest arrival that can be tolerated, we let the bus fall into the ongoing single time slot J plus O minus M minus 1. That means the maximum position duration caused by early arrival is M minus O minus 1. Okay, that is the description of time slot access and data flow. No questions, please come to the next page. For the admission control, there may be some work. We can see that firstly, traditional traffic regulation per flow is still placed under network entry. For example, the leaky bucket depth is set to cover the reserved bus resource. A leaky bucket read is set to cover the reserved bundle width resource. In addition, retains data for each subbus of the flow because different subbus may consume different time slots. And the optional function is that if the received traffic has random arrival time, an explicit buffer may be placed before the TQF scheduler to let each subbus obey its fixed arrival position within the authorization period. In later pages, we will see a synchronous runtime time slot mapping of the global style time slot. In this style, it does not relay the fixed arrival position. Okay. Please turn to next page. So this is the global time slot style. When workloads have the same time slot length and don't want to maintain the trivial mapping states per pass, the global time slot style may be useful. The key feature of the global time slot style is that for incoming time slot I that mapped to any ongoing time slot J, we always reserve outgoing time slot I. That means we have a constant O equal to the result of n plus I minus J mod n. If J is unfortunately equal to I, in an explicit buffer should hold the packet to let it fall to a new ongoing sending time slot J. So it's actually a special reservation strategy of outgoing time slot resource. The following table shows the comparison of different reservation strategies, and each strategy may get a special step. For the first strategy, if O is flexible in the range from 1 and less than n, it's a local time slot step. That means the time slot number is a local number of each node. The second strategy is that if O is constant to n plus I minus j, then mod n is global time slot step. That means the number of time slot is similar to one nodes. And the last, if O is constant 1, that means we always reserve the next time slot after the ongoing sending time slot. So it's actually the multi-cycle. Any questions? Okay, please turn to the next page. Okay. For global time slot style, there's an in-time variant. The key feature is that even under control plane, the constant outgoing time slot I is reserved for the incoming time slot I. A synchronous mapping from I to I. It may take a synchronous runtime time slot mapping from I to X and data plane, where X is a nearby time slot than I. This variant has work-conserving behavior, but not guaranteed. A possible implementation is that packets with incoming time slot I are still inserted to the queue for the time slot I, so that there is no possibility of overflow. Then each queue, if it is not empty, it will be how this is previous implementation is hardware. It will request authorization to send the packets for workers based on the load lobby. The queue for the current ongoing sending time slot had the highest priority. The queue for the next ongoing sending time slot has the second highest priority, and so on. The authorization bytes obtained each time may be, for example, 2,000 bytes. This is a per second maximum size for .NET service, so that to get unlimited interference latency by low priority queue. The queue for the ongoing sending time slot may request multiple authorization to clean itself. Okay, this is the last page. Any questions?
Carlos, go ahead.
Thank you very much. They're very interesting, good details also on the scheduling, everything. What's the difference over SCQF as presented by Xu 2 meetings ago?
I think this is interesting question because I have not seen much more detail about this curve, what the resource reservation. So I have not complete the comparison between the six curve. So I just I just presented the comparison between the CQF and the multi-CQF. So for other aspects, I think the difference may be that as you can see, we have construct the forwarding sources of the link, and that is aware by the network device, and that is under device, but not only under controller. That may be advertised by HP, controller or BGP. And second, that we decouple the authorization period and the security period, and I think that is a key difference.
It's very hard to understand you. Sorry. But
sorry,
so this slide does not have a comparison with SCQF, right? I mean, multi-CQF is the TSN proposal, right? So it's not one of the proposals here in DETNET.
Yes, we have not a comparison between the systems.
Mm-hmm. So yeah, maybe Xu has something to say. I'll step down.
Xu, go ahead.
Yeah, Carlos. Thank you for raising this point. Actually, that is also my question because for queuing mechanisms, the core question for the orders to answer is that how to guarantee the bounded latency and how to calculate, how to combine the queuing mechanisms and the resource reservation mechanisms to provide the bounded latency and bounded jitter. So I think, yeah, it is also not very clear to me what is the difference of these mechanisms and CSQF I have introduced. And if there is any, I think maybe some detailed comparison is very necessary. And as I have mentioned, the key point is that what is the difference about how to provide or calculate latency, boundary latency. Could you give me more details about this
Okay,
point?
thank you. Yeah, we have given the formula in page 50. David, can you turn the page to previous page? Some previous page. David? Okay. Indeed, we have given the latency formula in the slide and in the graph. Because as I have response to Taurus, I think sit careful. I have not more information about it, so I think it is actually not necessary to give a comparison between CSGF and the TGF. Yeah, that is my opinion.
Actually, as I've mentioned in my presentation, I think it is quite clear for CSQF about how to do this, because CSQF, the basic idea is that every device there will be cycles, and the controller, which has the global view, can calculate the time space that is requested for a particular DNS stream. And after the calculation is done, it can allocate the result as a segment routing, label stack, or SRH. I think I have give a quite clear presentation, or you can have some details in my draft. But for your work, I think it is still a little confused, that because I think it is just like what I have done. So I think it's better to clarify that what's more, or what is the problem in SQF, and why you want to solve it and how to solve it. I think it is very, very crucial from the beginning.
Yes, thank you. This is a good question. Okay. Just according to the presentation before you made, I have not seen much more detail about the resource reservation, and I don't want to see more information in the graph, in the CSGF graph. So if there's some similar procedure about the resource reservation and the scheduling behavior and the data plane, I think we may make a near comparison about these two mechanisms.
Because also as the author of CSQF, I am happy to see some following works. But from the beginning, I think you have to understand what has been done right now and give your proposal first. If you just repeat, I think it is meaningless.
No, it's not a repeat.
Yeah, so what's new?
I have just answered the question. I don't see any more information about the resource reservation in your draft and in your presentation before. And I have answered
Actually,
that,
I have give a very detailed reference at that point. I have given the paper, and there is a very, very detailed mechanisms about how to calculate the time stop for each stream. It's quite clear. And I think you have also asked some questions in the mailing list. I think it is also clear for you. So I'm a little confused that.
Okay, thank you.
Yeah. So I'm not sure you are clear what I have done and you want to repeat it, or you have found something new, you want to solve it. I think that is very, very the beginning of the question. If you have find, okay, there is some limitation and you can give further enhancement based on the existing work, I think it's great. And we can discuss. But if you just want to repeat, I think we don't, it is not necessary to have a new document about the similar mechanisms.
It
Yeah,
seems like
I think we can use the.
He has done something new, and I think it would be good for the draft to contain a summary of what distinguishes this from the CSQF work.
Yes, that is also my question. I think the distinguish is the start point rather than the similarity.
Okay. Okay. Issue? Yeah, Shafu, there's a lot of background noise coming from you, but I don't know if you can do anything about it.
Okay.
Can you hear me?
Yes, we can hear you. I think Shafu's only going to unmute when he after you've asked your question.
Okay. So my question is, I saw there was a quick flash on the UBS urgency-based scheduling. So my question is the whole work based on the UBS thing? Because it looks like you want to reference it. If so, I didn't find it as it is used as a reference in the reference section of the draft. That's the first thing. The second thing is, it looks like you are more or less is still reference to CQF in your slides. So my question is, how it is relevant to the UBS or CQF? Which one is more relevant? Which the fundamental mathematical end-to-end bounding latency calculation can be retrieved from which current standard or proposal or paper?
Sorry, it's wait a long time to unmute. So I'm not sure I have understand the question clearly. So the first one is that you see the UPS reference in the draft is no useful, right?
Based on the before forwarding that paper, improvement to that paper, or is it?
I have not got very clearly question. Maybe we can discuss in mail list.
Oh, that's all. Yeah. I saw you show that you kind of show the urgency based one, right? Or I misunderstood it. But yeah, okay, we can take it offline maybe.
Okay. Janu?
Thank you. Yeah, I will make it short. Could you go to the admission control slide? Maybe one or couple of pages before what we are seeing now.
All right, we'll try that. Oh, there it is.
Oh, great. Yeah, Xiaofu, thanks for the presentation. But I think you have to clarify the benefit of this approach compared to the other, slot-based schedulers. I first thought the benefit is about its flexibility. But as we see this page regarding the admission control, I think this is very complicated. I'm not sure what the state of each subburst means. The maintaining the state of the flow itself is not scalable, but maintaining the subburst, is it scalable, do you think? Thank you.
Thank you, Gino. Thank you, question. Um, uh, uh, okay, I will give a more description about the benefits. And as you mentioned, they should maintain the state for each subbus. Uh, in the current phase, we consider that each subbus may consume the specific time slot resource. Even for the same service flow, in the service bus interval, they may contain multiple subbuses and each consume specific time slot. So it's institutionally to let each subbus to use different time slot. So that is different stage for all subbus. Okay, we will try to get some optimization for this. Thank you.
I think Gino has give some point about maybe the difference between this document and CSQF. I noticed that Gino mentioned that the flexibility is the benefit you want to bring in this document. I think it's a good point. So maybe my suggestion is personal suggestion is to maybe add more descriptions about how to make it flexible based on the existing CSQF mechanisms. For example, how to handle the newly arrived flows, or how to handle the flows without resource regulation, if that is the point you want to raise.
Okay, thank you. We will give more detail about that in the future versions.
Any other questions? Turles, are you waiting to say something?
Nope. Oh, yep.
Okay, in that case, I think we might be done. Looking forward to some list discussion of some of the things we discovered about the requirements draft, and hopefully a revised version of the requirements draft sometime soon.
Just wondering, David, logistics. Do we have all the prior stuff up there, or do you still miss slides or something from anyone?
Everything's up there. It took Shusong a little while to produce a version of her slides that did not say Huawei Confidential, but she got it done.
Yeah, that's a classic.
I forgot to send it to you. Sorry about
It's
the delay.
posted. Yeah, nope, you got it done. They're posted. Okay, I think we're about done then. Thank you all very much for taking the time.